to do something on what's called the alpha channels, the splits, the hidden channels. There's many names for them, and there's two types of CB radios out on the market. There's this one here, which has just got a channel changer, which is the old school conventional CB radio. So this is my home base radio. This is my mobile radio, which is a newer radio, a Superstar 6900N, and this comes with a channel change, but it's also got a frequency readout in it. Now I'm going to use this to show you what I mean by the alpha channels, because if you've got this type of radio, you may not actually even be aware they exist, because when you change your channels, you go 1, 2, 3, 4, 5, 6, 7, 8. There's no gaps. It's just a consistent 40 channels. So it goes all the way from 40 consecutively all the way down to 1. So starting at 965, the channels jump up in 10 kc increments, and by that I mean if you go from channel 1 to channel 2, it goes from 0.965 to 0.975. So that is 10 kilohertz difference per channel, or 10 kcs is another term you may hear. So we move this one up to channel 2. So if we go up to channel 3, you see it's gone 965, 975, channel 3, 985, as you would expect. This one's jumped up to 3. So the next channel in theory should be 965, 975, 985. Channel 4 should be 995. Hang on a minute. It's gone to 27.005. And that one's gone to channel 4. So between here, 985, channel 3 and channel 4, there's actually 20 kcs difference, or 20 kilohertz. And that's where the alpha channels or the split channels come in. There's a hidden channel between channel 3 and channel 4. But as you can see on this radio here, same thing, it just does 1, 2, 3, 4. 1, 2, 3, jumps, 4. Now, on this radio, if you go to channel 3 and you press the plus 10 kilohertz thing, watch what happens to the display. There you go, 26.995. So that hidden channel does exist. And then you can go 27.405. So there is a hidden channel in between channel 3 and channel 4. And again, if you look on that alpha channel list I gave you, the one I use, it's got channel 3, 26.985, channel 4, 27.005, and then I've got 3A in a block, 26.995. All of these ones in blocks are alpha channels, and there's 5 of them. You've got 3A, 7A, 11A, 15A and 19A. So if someone says to you QSY to 26.995 and you're on this type of radio, you're going to lose them because you haven't got the alpha channels. On this one, I can just simply press that and I'm on the alpha channel. I'm on 3A. You might think, well, how could I add the alpha channels to this type of radio? This one comes with it. So on your older things, what do I do if I want the alpha channels? How would I be able to get them? And there is a very simple way of doing it, but obviously any modifications you do are at your own risk. Depending on the type of what's called PLL chip, so depending on, if you like, for use of a term, the brain of your radio, a lot of radios have in what's called a PLL02A, and it's a binary chip, and this is what's called a truth table. And for each channel you have what's called a binary code, so it puts a voltage onto certain pins of the PLL chip, and each pin has a value, and combinations of those, 1 means there's a voltage, 0 means there's no voltage, so 256 plus 64 plus 8 plus 2 gives you a digital code of 330. Now what you can see here is channel 1, 330, channel 2, 329, channel 3, 328. Here comes a jump, channel 4, 326. So there's a binary code missing between 3 and 4. Ideally you want 327. Now if you could actually make a binary code of 327 here, then in theory you could have the alpha channels. And the way you do that is you break into your CB, you cut this pin here, this track going to here, and you put a little flick switch in, and you have its center is off, which means normal operation. If you flick it to the left, it puts +8 volts onto the pin, so it adds a 1 in, and then if you flick it all the way to the right, it grounds the pin, which is a 0. So you can make your own encodes. You can add one or take one away to these current pins depending on what channel on. So if we wanted to make a little flick switch and start adding +8 volts, so putting a 1 on, or grounding the pin by adding a 0 to try and get the alpha channel, what we would have to do is we would have to cut the track, go into pin 15 of, as an example, the PLL02A. We would have to solder a resistor across it, then with a 3-way switch, center off. To the left we would put 8 volts on, that would then add a 1 here. Or if we flicked it all the way to the right, we would ground the pin and put a 0. So to get an encode of 327, which is the alpha channel, we would go to channel 4 and we would flick the switch to the left and put +8 volts on pin 15, which would add an extra 1 here, which would then add that up to 327, which would give us the encode, hence the alpha channel. Now to do that mod, you have to know what PLL chip you've got inside your CB, and you've also got to know what the encodes are, or the truth table is, which is this information here. Now there is a book you can get called the CB PLL data book by Lou Franklin. I'm not sure if it's still in print, it may not, but I think you can find free copies on the internet. Now the chip I've been talking about is the PLL02A, and there's a picture of it here, and these pins down the side here from P8 up to P15, these are the programmable pins that I'm on about. Now some PLL's chips are modifiable and some are not, and this book also gives you an example of truth codes as well. Right, and here's the truth chart for it. So 26.995, N digital codes 330, and then here's the pins here for your control. And you can see channel 15 has a binary weighting of 1, this one has a figure of 2, 4, 8, 16, 32, 64, 128 and 256. And pin 15 is always the pin on this one, the PLL 02A, that you would want to either put a voltage on or take a voltage off. So, oh sorry, it's not 8 volts, it's 4.5 to 5.5. So it's actually 5 volts. Sorry, not 8. And what you would do, the best way to do it is before you go in there cutting any pins, is work out what pin voltage you've got. So if all of these pins, when you read a voltage on them, is 5 volts, that's what you need to put on pin 15. That's probably the easiest way for you to work out what you need to do. So let's have a look at some more of these alpha channels. So if we continue up to channel 7, so 7 is 27.035, the next one should be 27.045. So we go to 7 to 8, it jumps to 55. So 35, 55, so there's an alpha channel in between 7 and 8, and lo and behold, if you look here, it jumps from 27.035 to 55, 323 to 321, 322. There's a binary code in between there. So to get to 322, we would go to channel 7, look at pin 15, ground pin 15, which would take that one off, which would reduce that by 1 and give us 322. So in this instance, to get the alpha channel 7A, you would go to channel 7 and ground pin 15. And again, if we go back to my original chart here, 7A, 27.045, So if we go to 7, I'll do plus 10 kilohertz, 27.045. There's the alpha channel. So I hope that gives you an idea of why they're in there. They are very useful for DXing. When skip's running, a lot of people don't necessarily have the alpha channels on the older sets. So you can find some clearer frequencies on the channels, and these are on each of the 40 bands. They just run on channels 3, 7, 11, 15 and 19 on each band of 40 channels that you get. So it's worth trying to put them in if you can. On this radio, I have a plus 10 kc shift similar to this. So all I do is I press in my PA button and it jumps it up 10 kcs. Take it off, takes it back down again. I can't see this because I don't have a frequency display on here, but I know this is plus 10 kcs. So what I do is I always get my frequency chart here, go to 27.035, which is channel 7, hit that button in, it jumps 10 kcs, same as this one, up. It always goes up. So I always have to be one channel less than what I want, press the 10 kcs and it jumps up. And that's how this radio works. And that's sort of how it would work on the older ones. But mine's always a permanent plus 10 kcs. On the one I'm on about, you would have centre switch off. To the left would be putting voltage onto the pin, back to the middle, over to the right, grounds the pin. You have to work it out a bit, but again, all you do is you would put here 7A, channel 7, plus 5 volts. Then you go 11A, channel 11, ground, or channel 12, ground. You know, you'd have to work it out for your particular radio. But yeah, it's definitely worth doing. A lot of people, as I say, these days use this, and I use this when I'm mobile. But to be honest with you, I prefer the old school stuff. These are okay when you're mobile, but the clarifier has only got one clarifier control. Normally you have a fine and coarse, so you can just move it around, you do it. But when you're driving, it's not easy to start pressing this in and then start playing around with the clarifier to get fine and whatever. So I prefer the old school one, where you can just move the clarifier. You can still be driving along, don't have to take your eyes off. You can do it by feel, move the clarifier and tune the station in. So that is why I prefer this sort of stuff. Plus they're easier to work on. These have got conventional components, these have got surface mount, and conventional's much easier to work on. But there's an insight of what I've got for my mobile radio. Does about 35 watts output, I think, is standard. I don't know what that's FM. I don't know what it does on sideband, but yeah, it works all right. So anyway, I hope that gives you some insight into the splits, the hiddens or the alphas, and if you hear that term now, you'll know what it means. And if you have got one of these old school type radios, then maybe you could consider adding the splits in if you feel you're competent enough to do it. If you don't, then get a technician to do it. Okay, that's it from me. If you've got any questions, post in the comments and I'll try and answer them. But I'm not familiar with all types of radios, but yeah, I'll see what I can suggest. Okay, thanks for watching.